Okay, good morning and welcome to the webinar today. My name is Carrie Berger and I'm the coordinator for the Northwest Fire Science Consortium. For those of you not familiar with the consortium, we are one of 15 fire science exchange networks across the U.S. that are funded by the Joint Fire Science Program. Part of our mission here in the Northwest is to disseminate regionally relevant information to our stakeholders in Oregon and Washington. And so we try to do this by offering a diversity of opportunities for people to participate in, and hosting webinars is just one way we can accomplish that. So I encourage you to visit our website to learn more about the consortium and to sign up for our monthly newsletter if you're not already on the list. Our website information can be found in the chat box at northwestfirescience.org. So to avoid any noise interference, I have muted your audio. So if you have a question, please type it into the chat box. Also, I'll be recording the webinar and will archive it on our website and YouTube channel. In fact, I record all of our webinars and we have a large archive of webinars and videos just waiting to be watched. So go ahead and write down those web addresses that are listed there for you in the chat box. Okay, so I'd like to welcome back Josh Clark. Josh has been giving us these Fire Outlook webinars for the past several years now. Josh is the meteorologist for the Washington Department of Natural Resources. He specializes in fire weather and applications of weather in forecasting fire danger, smoke impacts, and forest health. Josh is also part of the Northwest Fire Science Consortium Advisory Board, and we certainly appreciate his participation and expertise in that group. So Josh, whenever you are ready, go ahead.
Yeah, so can you see my screen, Carrie?
I sure can. Looks great.
Great. So thanks, everyone, for coming to attend this webinar today. And yeah, I've been giving this talk to the Northwest Fire Science Consortium for the last few years. And so those of you that have seen this talk before are probably going to recognize the format and everything. But, you know, a lot has changed when we look back at what 2018, 17, and the 16 outlooks looked like. So before we get into that, just kind of looking at where we're headed for this talk. So what is a normal fire season, some typical fire season factors that we're looking at, preseason conditions that have been in place, our summer outlook, and most of this is going to come from the Predictive Services and the Climate Prediction Center, and then just some summary takeaways. So, you know, what is a normal fire season? And this is unfair to the Oregon folks, but this is basically Washington, and some of the things here translate over across the border, but for us, it's generally July-ish through September. Begins with these lower elevation cured grasses, 100-hour fuels, especially along our I-5 corridor through the Columbia Basin, and a lot of escape debris burns. So folks are out burning. It's springtime. We get a wind event or whatever, and we get a lot of escape burns early in the season, especially around June time frame, late June. And then human ignitions peak July 4th, and you can see that on this graphic to the right, where we have the average number of all fires per day over this fire occurrence data set here, and really just a huge spike, almost a fourfold spike on July 4th due to those recreation-type fires, escape campfires around the holiday weekend, or the holiday. Lightning busts become increasingly likely July 20th through August 21st-ish, so that month period is kind of our climatological peak season for lightning ignitions. So we think about those in combination with the typical human occurrences that we have due to recreation or campfires or whatever. Really that kind of sets the tone for our ignition source and sets the tone for our fire season. How fire season normally goes is heavily dictated by these critical fire weather events, which are these east wind events that we've seen in March, just this past March, ridge breakdowns and the associated dry cold fronts that come through, and then, of course, any type of abundant lightning-type ignitions generally overwhelms our initial attack capabilities, producing new campaign-style fires through July and August timeframe. We look at the stats. Again, this is just for Washington, but looking at acres burned and fire occurrence kind of on a running 10-year average here, acres burned for us last year was just slightly above the running average, and typically we come in around 300,000 acres or so.
Hey,
When we
Josh.
look at fire, yeah, hey.
I'm sorry to interrupt you. This is Carrie. You're cutting in and out a little bit on the audio.
Okay, strange, yeah. I'm on my work desk phone here.
Okay. It's not too bad. It's just happened a couple times, but
Okay.
I didn't know if you were maybe on your cell and like waving your hands and talking. Sometimes
No,
I
I'm
do
not.
that and it hits the audio. But
Yeah.
so just go ahead and I'll let you know if it becomes a problem.
Sure. Yeah, I just checked all the connections here. Yeah, I'm on the.
Getting notes that people say you sound good to them. So let's move on.
Okay.
Sorry about that.
Cool. Yeah, no worries. So just looking at Washington fire occurrence and acres burned, what I want you all to take away from this is in operations we typically use these two metrics to define what a fire season is, right? When we go back in retrospect and we say fire season was above average or below average, we look at these two metrics, a lot of times, and I argue that they're probably not the best descriptors, and the state of the science suggests that we are maybe moving away from these, right? These will always be the most tangible things, right, that we understand, that we can wrap our heads around, but look at the trends, like look at the difference in acres burned, how variable it can be, and then look at, when we describe fire season in terms of occurrence and acres burned, how poor they are, how poor of a relationship they have, right? 2009, where we have an extreme amount of new fire occurrence, but very insignificant amounts of acres burned. Or 2013, where a similar thing happens, where you have above average fire occurrence, but again, really low acres burned. So, a lot of times we try to paint fire season, and one of these or both of these. I think maybe that we can describe fire season better by looking at total man hours or incident management teams assigned, something that has to do with our level of response to these fires. And know that the agency's mission, weather, fuels conditions, resources that we have in the geographic area, and the number and distribution of fires all influence this season classification. When you look at what happened in DNR, so ODF made a graphic like this, so we had to steal the idea. But this is, I think theirs goes back even further. But yeah, 1928 to 2018, number of fires, where yearly fires is in blue and acres is in the red line, and the 10-year running average acres per fire are the black diamonds. Basically, what we're seeing on DNR protection is that we're having lower fire occurrence and increasing acres burned and increasing average acres per fire. So, you start thinking about that metric and saying, okay, well, then maybe they'll want to paint fire season in terms of acres burned. DNR's mission is new initial attack, right? It's 95% of fires under 10 acres or less, and that's going to change, I'm sure, with the inevitable climate change and forest health and WUI interactions. But right now, it's 95% of fires under 10 acres or less. So because of that, you're going to hear me talk about fire season and what fire season is going to look like, and know that I'm talking in terms of new fire occurrence, right? Not acres burned, not total incident management teams assigned, just strictly new fire occurrence. So that's an important distinction to note when you hear these seasonal outlooks from myself, John, or Eric, or another National Weather Service meteorologist. Try to get at what they're saying in terms of fire season descriptors, right? Are they saying just the weather, fire occurrence, et cetera? So when we look at some of the factors that drive fire season, we have basically 6 things in place, and that we're looking at for forecasting fire season. These end-of-season fuels conditions, where we ended up in October last year. The October to May rainfall, so how well we're going to be rebounded, how much rainfall we've had to maybe mitigate the dryness that we had in our fuels back in October. The state of the snowpack and subsequent timing of that runoff, So how early or how late it occurs can influence fire season activity. And then, of course, summer weather and the response by fuels and how summer weather is modified by extreme events. And then we don't have a fire season without lightning-caused ignitions or, in the case of the last several hundred years, number of human-caused ignitions. So it's important to know that human-caused ignitions, right, are a major driver of fire season activity. In the Rocky Mountain area, where you have 5 states that experience abundant lightning patterns, right, that may not be the case. These numbers may be skewed where there are more lightning ignitions than human-caused ignitions, but in the PNW, about 70% of our ignitions are caused by human starts. So they modify. We modify what a natural fire season looks like, the frequency of which, seasonality, location, et cetera. And I'm kind of foreshadowing a bit because human-caused ignitions are going to play a very critical component this year, especially since we are going to start hinting at an above-average risk of fire activity for the western side of Oregon and Washington. All right, looking at end-of-season fuels conditions. So where we were in 2017, end of fire season, where we were end of fire season 2018. Right, and we're putting this graphic on the left here so you have kind of a gauge of what last fire season looked like relative to these graphics. So coming out of fire season last year, we had severe, extreme drought throughout much of Oregon and even severe drought extending all the way up into kind of our southwest interior zones of Washington. Basically drought conditions across the entire west side. And not so much the case back in 2017, where we just had abnormally dry conditions for much of Washington and maybe central Oregon, where the major emphasis was these dry conditions that were present in the northern Rockies. But the big thing here is the state of our fuels, right, the state of drought concerns that were present through Oregon and western Washington back in October. So we have a lot to kind of make up for through kind of the October to May period. And we can kind of look at what has happened since then in terms of temperature and precipitation. Well, since then, the last 6 months' temperatures, we've been mostly near normal. There's some deviations at higher elevations where we've had above average temperatures, 1 to 3 degrees above normal, and cooler temperatures throughout much of the Columbia Basin, maybe 1 to 3 degrees below normal. And in terms of precipitation for the last 6 months, we're trending about 60 to 80% of normal precip for the water year. And that's for mostly western Washington, northwestern Oregon, and the coast, and all along basically Okanagan to Pend Oreille counties there along the international border. It's kind of an interesting graphic when you think about what this usually looks like, right? This usually is kind of the opposite, where we have the Columbia Basin is trending below average in terms of precip, and the west side is usually above average. And then we're observing similar conditions in Idaho and Montana as well. So, that's not this alarming, right? We're 60, 80% of normal. That's not the world's biggest deal, but there have been these kind of extreme events that have happened, right? We're experiencing one now, in this very, very hot and dry upper level ridge that's in place and going to be amplifying over the next few days. And back in March, when we had a pretty significant east wind event and brought about 45 new fires in western Washington over the course of 3 days. And that was coming off of this right here, these temperature anomalies, precip anomalies for the month of March, where basically we saw above average temperatures at all of our elevated zones in Washington and near record low precipitation for the month of March for all of western Washington as well. Anything that's highlighted here in this dark brown is at that record low value. And, interestingly to note is basically the entire east side low elevations were all significantly below average in terms of temperatures. And we look at kind of the 60-year period that led up to that east wind event, 60-day period, for February and March, we had record low precip values even into February across the Olympic Peninsula and the North Cascades. So, we haven't done very good in terms of precip, especially kind of February and March timeframe. April kind of pulled things back, but now we're right back in a scenario where we have a much less precipitation than we usually expect for kind of the first, second week of May. And looking at snowpack, so this is where we were before fire season last year, May 7th, today, this time last year, and this is today's snowpack. So what is snow water equivalent? It's the amount of liquid available in a column of snow should it be melted instantaneously. So just allows us to measure the amount of liquid in snow. Basically, the entire western U.S. was trending below average, below kind of this median, this climatological median for total snowpack. Even Oregon, Nevada, Utah, Colorado, and Washington, and the Northern Rockies, Idaho Panhandle, and Western Montana were faring really well. And we saw that kind of play out, right? We saw Oregon was in significant drought concerns in Central Oregon. This time last year, there were numerous news articles that suggested, Oregon was in a drought emergency, and we know that these places, the Great Basin and such, had pretty good fire seasons. And last year was kind of a normal fire season for us as well. Then we look over here at the graphic that's from today, and interestingly, all of our Cascade basins are trending pretty well below average. This is the second lowest snowpack we've had since 2010, right? 2015 being the other kind of below average snowpack that we've had. And, I'm not making any real direct comparisons to 2015 because this time in 2015, most of these basins had no snowpack or less than 10%, right? So we're still well above that. But just know that this is only the second year in the last 10 years that has been below average, at least for Washington. And then looking at soil moistures, basically this is for the last month or so, April, and soil moistures have been well below average for much of Washington, northwestern Oregon. This looked worse when it included March, of course, but we've had record low soil moisture values for much of the Olympic coast, the Olympics, and then extending, of course, all along the western side of Washington. And again, right, a similar pattern here in kind of the northern Rockies area as well. And you think about all these factors that we've talked about, right, temperatures, precip, snowpack, soil moistures, et cetera, and that all goes into this drought outlook. And this drought outlook seemingly indicates that we are currently experiencing abnormally dry conditions with moderate drought concerns through Okanagan, Chelan counties, and just a little bit into Kittitas Valley here kind of in central Washington. So that's kind of the primary concern, and that was the primary concern a month ago when we issued a drought declaration here in Washington. I would imagine that we're going to see this. This graphic is going to show that Western Washington is going to be significantly more drought concerns as we progress into May, June, and July. So now kind of transitioning to summer outlook. So a lot of times I get asked, are we in El Nino or La Nina, and what are its effects on fire season? So the things that we're typically looking at here are on the left, and we're looking at sea surface temperature anomalies kind of around the equator, and that's going to be in this weird sector 3.4 zone or whatever, and you can see that's just kind of a fragment of this location right here along the equator. Yeah, it's been correlated to have an impact on North America temperatures and overall weather. But basically looking at this zone, 3.4, we've been above average in terms of sea surface temperature anomalies, or above normal for sea surface temperature anomalies. And all of our models that go into forecasting that go into forecasting ENSO. So these are dynamical models up here, And then there's some statistical models that look at it from a regression kind of standpoint. But the major focus should be right here on the red line, that they're all showing kind of this forecast trend, at least through the winter, of above normal sea surface temperature anomalies. So we're going to be about 1 degree Celsius above what normal would be. And so this indicates a weak El Nino kind of in place, and the Climate Prediction Center has shown about a 65% chance that we're going to have El Nino continuing through the summer and about a 55% chance continuing through the fall. What does that mean for us? A lot of folks think that El Nino has this kind of direct effect on what happens in the winter or what happens in the summer, and that's not really entirely true. And so it has no real direct effect on summer weather. Basically, it's just indirect. So what happens in the winter? So how El Nino modifies what occurs in the winter, of course, has indirect effects down the road for what we experience during fire season. So, in an El Nino type situation, we have warmer temperatures through the winter, more precipitation falls as rain, overall less precip. And we've seen that, right? We've had El Nino conditions in place over the winter. We've seen less snowpack, more precipitation falling as rain, and we've seen temperature anomalies, especially in our high mountainous zones, above average. We have La Nina conditions. Of course, we get colder weather, more precip as snow. Overall, more precip, and skiers rejoice because that usually means there's a lot of fresh powder in the mountains for them to ski on. Looking ahead at what we're expecting in terms of temperature and precip. So this is the 1 month and 3 month outlook from the Climate Prediction Center, and there's above average confidence, especially in the 6 to 10 day window, right? We're looking at temperature departures from normal in the 6 to 10 day window in excess of 20 degrees, right? We're seeing 20 degree above normal temperatures on the west side likely this weekend, and so that's going to pretty much skew this 1 month outlook here. But for the 1 month period, we're expecting above average temperatures for much of western Washington and Oregon, and still kind of continuing through the remainder of the Pacific Northwest with less confidence. And then for the 3 month period, that's going to be, again, above average confidence for above average temperatures for basically western Washington and western Oregon as well. And then looking at precipitation, below average precipitation is expected for the Pacific Northwest in both the 1 month and 3 month period, with less confidence given to the 3 month period. But basically you can see where we're expecting, right, the most critical fire season concerns, right, is really highlighted here in this 3 month outlook, where it's kind of that northwestern portion of Oregon and basically all of western Washington. And then the U.S. Drought Monitor suggests that we will just see more drought development occurring for much of kind of the northwestern portions of Oregon, north central Oregon, and the entirety of the western side of Washington, and then, of course, Okanagan and Chelan counties up there in kind of north central Washington. So you put all these factors together, and Predictive Services has issued these outlooks for the next 4 months. And so this is the next 30 days, May outlook. And so what is significant fire potential? It is large, costly fires. Predictive Services and the regional coordination centers are concerned about large, costly fires. Although they do new fire occurrence as well, these maps are large, costly fires, which would challenge kind of our large-scale resources, right, our LATs, our VLATs, our Type 1 crews, et cetera. And there's above average risk for significant fire potential, so above average risk for new large costly fires in May for much of western Washington and northwestern Oregon, and that continues through June. And then in July and August, basically this starts to encompass the entire western portions of Oregon and Washington, and then our northern tier counties in the Idaho Panhandle and Okanagan to Pend Oreille County, and then continuing, of course, through August. So it's kind of interesting, right, when you think about Usually this graphic shows kind of the east slopes of the Cascades and the Columbia Basin and the Blues, right? And of course Okanagan, always, every year, as being under the gun for large, costly fires. And this year things are kind of flip-flopped, where we're seeing much of that potential risk being on the western side of the Pacific Northwest. This is just a reference map for these next graphics I'm going to talk about, and these are going to be fuel moisture curves. A lot of operational folks should be familiar with these, but these are just kind of the areas we're talking about. This is how DNR kind of defines, our fire danger risk from a broad scale and how we relay it to our fire managers here in Olympia. But we're going to take a look at the kind of interior lowlands, western Cascades, and the southwestern Cascades. And some things I want to show here. So this is the interior lowlands. So basically all along the Puget Sound here, even down into kind of Lewis County, Thurston County. So we're talking South Puget Sound now. These are maximum values of 100-hour fuel moistures and maximum values of 1,000 hours in red. The gray line is the average, and the blue line is the minimum value. And the pink line is where we currently are. And, things I wanted to show here is that 1,000 hours in a lot of these places are at or what we've observed in the past, average values for about the month of July or August, right? They're currently trending very, very low, very much similar to what we'd see in July or August. So that can be reflected here, and you look at the western side of the Cascades, and kind of draw this pink line over, right? And that's about the same as we've seen average line in August. And then looking at 1,000 hours, so 1,000 hours are trending about what we would normally see in July for the western slopes. And then in the southwestern Cascades, looking again, right, this is about middle of July, and then about the beginning of July in terms of what average is and how these fuel moistures look in comparison to that. So I wanted to show those. We just put those together just yesterday because I think it paints a good picture of how things currently look, right? We talked about this as meteorologists with regards to the March complex and the 45 fires we had in western Washington back in March, right? That the weather was there, that we knew 50-mile-an-hour gusts from the east and 81-degree temperatures and RHs in the teens for the Olympics and the Cascades. The weather was there, but we didn't know that fuels would be so responsive. And you can see that just in the last week or so, when we've had this kind of hot and dry conditions in place, that fuels have been particularly responsive. Fuels started out much lower than they usually are in a lot of places, right? Look at 1,000-hour fuel moistures for the western slopes of the Cascades. Started out at about 17% here, and they usually start out at about 23, 24%. So our fuels aren't in the best shape for western Washington. So what am I trying to say, putting this all together? That we've had below average snowpack in place and basically below average rainfall in place for February, March, and now the beginning of May with near average temperatures. And so all of that put together, all of these things that we've looked at indicate an above average risk for a pretty good fire season for western Washington, northwest Oregon, and then extending into Okanagan and Chelan counties as we get towards July and August. One thing here is that there's nothing that really indicates that we'll see an above average or below average fire season in terms of fire occurrence for the Columbia Basin, the Palouse, the Blues, because a lot of their fire season is driven by lightning. And if we get just a couple lightning busts or whatever, that can heavily modify what their fire season looks like out there. Short and long-term climate projections indicate an earlier start to summer, right? We just kind of talked about temperature departures going into this weekend are expected to be 15 to 25 degrees above normal. We're going to be in a very hot and dry regime through about the 15th. I shouldn't say very hot. We're going to be in a warm, dry regime through about the 15th or so, and that's going to do a lot to our fuels and to our snowpack. And just think about how fast things usually change here in Washington and Oregon, right? We go into fire season really quick. We don't have these profound shoulder seasons like some of the other geographic areas have, right? We just, boom, we're in it, starting in July or so. And we maintain a pretty aggressive tempo for about 2 to 3 months. And then we have a season-ending event or so, and things kind of shut off. So just be mindful that that could occur earlier this year as our fuels are going to be trending. They're going to be curing out sooner than normal typically. So there's this moderate to high confidence that Western Washington and Oregon will see an above average fire season. And I put this shameless plug in here. I always say this anytime we have this kind of risk, this challenge, because I want managers to be aware of what this does to their personnel and to teams across the GAC. Think about just last year where we're calling it just a near normal or slightly above normal fire season, and we exhaust all of our incident management teams, right? We exhaust our type 1s and type 2s, and we're saying that was kind of near normal. What happens in a season where we're expecting these above average conditions with good confidence, right? This challenges our resource availability, increases the demand on personnel committed to incident management teams, and it's going to increase our demand on, basically large assets across the geographic area and nationally. The good news is it doesn't look like there's going to be too much competition when we look at things from a broader west-wide perspective. Of course, California seemed to be under the gun for significant fire potential, and the northern Rockies, but thankfully those are located fairly close. So that's just something to be mindful of, that there are other places that are going to be entering fire season or at the peak of their fire season when we're entering fire season, and resources may be scarce. So that's all I have. Usually these go really quick, and then I like to just take questions and talk. Yeah. Any questions? Carrie. Hello.
Can you hear me now?
Yeah.
Hello?
Hey, Carrie. Hello.
Josh, can you hear me now?
I can hear you, but I don't think you can hear me.
I can hear you.
Okay, good.
Okay. Oh, sorry about that. I think my headset is acting a little wonky this morning. So let's see. We have a question that came in. Thank you so much, by the way, Josh. You missed that part as I was dealing with my audio. Thank you so much for your presentation. Like you said, we will open it up for questions. Get your questions into Josh. We do have a couple that have already come in. Let's see here. Let me just does this fire trend extend into British Columbia?
Yeah, I believe so. And there's actually a really good graphic that John Saltenberger has put together in regards to this that I believe shows a significant risk or an above average risk for fire potential there. I want to see if I can pull that up actually, because it's just really quick here. So I'm still sharing my screen. And so most meteorologists here in the PNW produce an outlook similar to this, and John and Eric produced an outlook that is more geared towards kind of the Northwest as a whole. And then I focused my outlook on Washington, and ODF probably does one similar for Oregon. But there's a graphic here that John has that shows the expected risk for British Columbia and across much of Canada, right? So it looks like they're expected to see an increased fire risk in June and then possibly in July as we get later into the season. So yeah, it looks like it extends across much of Canada, but yeah, it does look kind of honed in there on British Columbia.
Okay. There's a question that asks, what are the grasses looking like?
Yeah, so I mean, 1 and 10-hour fuels are going to be highly variable, of course. I think we did see an earlier green up, especially in Western Washington, and with that, with the way that the weather is trending, we'll probably see earlier curing of those fuels, and thus they'll become more volatile, more susceptible to fire as we get closer to kind of June, instead of maybe July, right? We're expecting here at DNR to see fire season starting kind of earlier in terms of our responses and the number of people committed to new fires. So, and a lot of that is going to be driven by grass and shrub type fuels because they greened up faster, because they're going to cure out earlier in the season.
Mm-hmm. And so what do you think is the best fuel moisture indicator for fire potential in Western Washington, specifically 100-hour fuel moisture, 1,000-hour fuel moisture, or energy release component?
This better not be Scott Wayshaw or Sean Weigel or something. No, this is a problem. This is something we're talking about in Western Washington for me, John, and Weather Service in Portland, because there was that March complex event where we had those fires, and there was no red flag out because there is no out-of-season criteria for red flag warnings in Western Washington because those events are pretty rare. And so that's something we've been wrestling with, is what is the best indicator of fuels and their response to short-term weather in Western Washington. And so we've kind of wrestled with, is it 10-hour fuels, is it 100-hour fuels? I don't think it's 1,000 hours because you're not going to pick up on extreme events like, an east wind event with 1,000-hour fuels. So I do think it's probably going to be 100-hour fuels.
Mm-hmm.
If I had to guess, but I haven't taken a look at that and tried to bring it down to see how accurate that is or what kind of relationship there is.
Mm-hmm.
In terms of 100-hour fuels and new fires are area burned. So.
Okay. So if Western Washington and Oregon have typically longer return intervals for wildland fire because of being generally wetter than the east side, what does an increased fire severity, I'm sorry, I lost the question. What does an increased fire frequency in these areas mean for potential fire severity?
Yeah, there's probably a fire ecologist on the line here. What does that mean for fire severity? Is that correct? Increase in. Yeah, I don't know if that an abundant new fire occurrence means anything in regards to severity of fires. I would say that fuel dryness, right, how dry things are in our 100 hours and 1,000 hours are going to have more to do with severity. I guess maybe we're talking like consumption of fuels or what the effects are. That I don't really know, right? As a meteorologist, I care mostly about forecasting when and where it's going to occur, and then the after effects I leave to an ecologist. So
I imagine, given the abundance of vegetation on the west side, that there could be potential for, higher severity fires with all that fuel. But I'm also not a fire ecologist, so
yeah.
So this person asked a question that I had in my mind. Has there been another fire season since we've been tracking with similar tools with this kind of significant fire potential in Western Washington? If so, what year and what happened?
Man, that's a good question. That I don't know for certain. This is kind of, I would imagine there is a case out there like that. I know in 2014, similar events kind of happened in the early spring where there was kind of an east wind event. There were these anomalous high pressure conditions in place over Western Washington and Oregon. But I haven't taken a look at what these significant fire potential outlooks look like, going back, right? And it would be definitely worthwhile to take a look at that, but I don't know for certain. That would be a great question for John. He would definitely know that. John's been around as long as I've been alive, so yeah.
And hey, Josh, is your PDF of this or your presentation here, could I get a PDF of it and share it to some folks? They've been asking online here if they could get that.
Yeah, that's fine. Okay,
great. So if you have another question for Josh, please get those in. In the meantime, while we're waiting for more questions to come in, I just want to let you know that there's the consortium is hosting one more webinar. It's actually happening this Thursday on May 9th with Corey Blankenship and Jim Smith with the Nature Conservancy, and they'll present on what's new in landfire remap. So if you can, tune into that. If you can't, don't forget we do archive all of our webinars on our YouTube and our consortium website. So let's just check if anything else has come in. Oh, great, and just more people asking for a PDF, so that's wonderful, thank you.
Sure.
Well, if there's no other questions, Josh, thank you so much for taking the time every year to come to us and tell us the outlook for the fire season. This is a highly anticipated webinar for me and I'm sure a lot of other people, so thank you so much for doing that. I do have one more question that came in. Is the Department of Natural Resources
lost you, Carrie?
Josh, can you hear me?
Now I can. Yeah, you've come back.
Okay. Sorry about that. I'm not really sure what's happening with my headset here. So is the DNR planning resources differently given this outlook that you talked about today?
Yes, very much so. This is something we've been kind of tracking since March, and things I don't believe have really changed since then. We've predictive services at a national level, and John and Eric have done a great job at indicating Western Washington as being under the gun for above average fire potential, starting as far back as March. And that hasn't really changed since then, and so we've been well aware of this for a long time. We've taken steps to a lot of times we put the majority of our rotors, our helicopters on the east side, anticipating, of course, that that's where we're going to see new large fires or abundant new ignitions. And this year we've started putting a lot more on the west side, so those are already staged. All of our pilots are trained and ready. We've brought on seasonals a lot earlier this year, and generally we're just moving at an accelerated pace here. It's kind of a sight to behold, right? We're kind of accustomed to this being our May being our training month, where we're sending folks to academies and taking PAC tests and everything. And we're pushing up that timeline in anticipation. And I think that we're doing a really good job, especially with our public messaging on what happens in the short term. Our Commissioner Franz has already been indicating that we're at risk for above average fire season in Western Washington. But also you're going to see messaging coming out over the next few days about the risks that we'll have for Mother's Day and possibly even like Memorial Day weekend as well. So I think we are doing a good job. We're ready, and we've taken a lot of steps based off of this outlook to get ready for a fire season that possibly starts earlier and a fire season that is in Western Washington more so than maybe Eastern Washington.
Mm-hmm. Josh, are you there?
Yep.
Okay, great. Thank you for that. So no other questions have come in. I appreciate you taking the time to answer all these questions. I will get the PDF out to folks who have registered. And I also just want to say there is a short survey at the end of this webinar that I encourage you to take. The information you provide helps us to measure impact from the webinar that you just listened to, as well as it offers an opportunity for you to list future webinars that you'd like us to host. So do please take that survey. It's super short, I promise you. Yeah, so I just, thanks again, Josh. Thank you, everybody, for tuning in today. Have a great rest of your day.
Yeah, I do want to, Carrie, can I say real quick?
Yeah, absolutely.
So although my outlooks are mostly for internal use and they're mostly DNR specific, but I do want to point you all, if you're not aware, I know the majority of maybe operational folks are aware of these outlooks, but you've heard me refer to John, Eric a couple times, but they're the predictive services meteorologists at the Northwest Coordination Center, and they produce a very similar outlook that can be found on the Northwest Coordination Center's website. And so just going there and clicking on outlooks over on the left, and you can see basically their outlooks and then the national, monthly, and seasonal outlooks as well that are produced that are more encompassing of the entire Pacific Northwest and without so much emphasis on Washington. So just know that those are always there, and they're updating those once or twice a month, just in case you can never find this presentation again or want to see an updated version.
Yeah, that's super helpful. Thank you for that. Maybe I'll provide that link with the PDF as well, so folks have that. Well, thank you so much. If there's nothing else from folks in the audience, we'll call it good. And Josh, we'll see you next year this time.
Yeah, talk to you then.
Thank you so much. Okay.
Yeah, bye.
Bye.